Hello friends, welcome back. I am back with my new webinar number 28. This time on the best operation and maintenance practices of distribution company. We at WhatsApp group on Igniting Power Engineers have mentioned and have already shown our concern about electrocutions, electrical fires, death, failure of equipments, interruption of power supply, negligence and unawareness of people with respect to rules and regulation and the best practices not being adopted by utility in India. If we look at the word safe conditions and unsafe conditions, there is a difference of two words, U and N. U itself denotes many things. It is unawareness of people about rules and regulations. And N itself denotes negligence of duties and safety procedures. Further, I feel we have to use the latest technology, cutting edge technology we have, state-of-the-art technology we have. We have to adopt best practices of other utilities. We have to do the condition monitoring, etc. And the most important part, we have to use IT and artificial intelligence to maintain our equipment in good health. To understand the above points, I mentioned I have invited very special enthusiastic engineer who will share his experiences on best operation and maintenance practices in a distribution company, respected Nagendra Shekhar ji. Before I invite him to start his presentation, I would like to start with a Thanksgiving. And first of all, I would like to thank my parents, Almighty, my son, my wife. My mentors include P.P. Bhai Saab, Anjuli Chandra ma'am, K.K. Murthy Saab, N.K. Mittal sir, P. Ramachandran sir, S. Pao sir, Hitesh Chauhan ji, Dr. Kamal Bansal ji. When we talk about the friends and the well-wishers working behind you, were giving you support every time, include Saket Gupta ji, Arvind Tukral ji, Dinesh sir, S.K. Batra ji, Vishandat ji. Last but not the least, my team working 24/7 to make this webinar series happen, includes Gulab and Ramdhani. Now, time to give a brief introduction about Nagendra Shekhar ji. The very first introduction of this great personality, loving personality, is derived from the working, he starts from the company he's working with, BRPL. If you look at this word, 4 words, it explains itself many things. He's very brilliant, he's resolute, he's passionate, laborious, good-looking, very handsome engineer. He joined DESU DBB in 1993, almost 30 years ago. It's a big thing. And he has rendered his services in almost all the departments, including O&M department and training department. We talk about his contribution. He has been instrumental in setup of in-house switchgear workshop. He was the person who brought safety revolution in the organization. He is associated with NPTI, CBIP, Power Skill Council, and disseminating his knowledge and experience. He has played vital role in restructuring of Ethiopian electricity utility, and he has given training to all the engineers, almost all states, starting from Kashmir to Kanyakumari. He has been part of faculty development programs of university, includes DTU, UPS, Gautam Buddha University of Noida. If we talk about the qualification he has AMI, MBA, LLB, and he is the person who can talk on any subject you start with. Presently, he is working as a senior vice president in BRPL BSS Rajdhani. Above all, he is a good human being, my mentor, and my good friend. Now, without much ado, I would like to hand over this stage to Nagendra ji to make this stage on fire with your knowledge and experiences you have. Welcome, sir.
Thank you, Rajesh ji. Actually, what I believe that when you are a friend of someone, you ignore all his faults and mistakes and try to make it large. So I'm not as much as good as you mentioned. I'm just tiny. It's better that I'm your friend only, nothing else. So we have learned a lot from each other, and you are my guide also. As on date, I'm pursuing PhD just because of you. You pursued me, pushed me to apply, and finally I got it.
Thank you.
Got admission. So under your guidance, I will definitely got that also. Thanks a lot.
Now you
So
can,
shall I start with?
yeah, share your screen, sir. Make it full screen. Great. Please go ahead.
Once again, good evening to all. I'll try to share what I have learned, though the time specific is very limited. We have to complete this within next 60 minutes or even less. So I'll try my best to complete the basic issues. What is best O&M practices of Discom? The first question comes in our mind. The people who are not working with Discom, either they are with the faculties or in industry. What is Discom? Discom is a distribution company which has a licensed area and take care of electricity distribution. Because now electricity is divided into three different arenas like generation, transmission, and distribution. Distribution means the electricity company who acts like a interlink between transmission and delivers power supply at a usable voltage to the end consumer. So whosoever have license for distributing electricity in particular area has duty to maintain, operate, and even if required, design and develop a power distribution network or system. IEEE defines it in section 3.1.1. The definition is there given here. Electric power system EPS, facilities that deliver electric power to load. The single line definition, all the facility that includes our grids, our underground cables, overhead lines, our switch gears, our distribution substation, service lines, and meter also. At meter outgoing, the supply connects with the wiring or the arrangement of power drawing by the end consumer. As I told, EPS operation means all action including operating, monitoring, maintaining, and repairing the power system. Now, what is the maintenance? As most of you are well experienced, learned people, engineers. So maintenance is something to keep a machine or a system or a equipment running or in productive conditions with safety and reliability. The two words we have to focus. A machine can run, it may be producing, it may be productive, it may be generating, or whatever, even a system like power distribution system. But we have to focus on two things. One is safety. So whatever it is doing, whatever task it has to perform, it is performing with safety and reliability. So we can rely upon it. And well-designed commission maintenance is essential. It is basic need for a trouble-free operation and cost-effective functions for anything, including power system, power distribution network. Maintenance comprises basically all technical and associated administrative actions to keep a system running as per the specification. So technical, all we know, the operation, maintenance, taking care of. Administrative means making policies, back-end support, as just now our Dr. Rajesh has said that running the show, there is a back-end team which works 24/7. So maintenance means there are a team also which is working back-end that may be providing you support for materials, may be providing you support for shutdowns, may be providing you support for procurements or designing and developing some tools, some materials which may be useful for your maintenance. Maintenance basically of three kinds. One is preventive maintenance, which is scheduled maintenance. So you have a schedule that after certain period you will do this or that. So it means maybe after 10 trippings or earth fault trippings, 18 earth fault trippings, you have to change oil of OCBs. The previous versions, nowadays we are using SF6 and VCBs, or changing of our silica gel and a breather after a certain time, that may be yearly, 6 monthly, half yearly, hourly schedule. It depends upon. Whereas non-scheduled maintenance are breakdown maintenance. When a machine or system is stopped working, it is out of operation because of anything, then you have to make efforts, collect everything and put that machine or system into operation. So basically in power distribution system, any breakdown means the failure to supply electricity to the end consumer. So when it happens, you have to ensure that everything will be set right and the power is restored to the consumer. And third is predictive or condition based maintenance. Predictive maintenance is something when neither it is scheduled nor there is breakdown, but something is noticed which may result into a breakdown, like partial discharge. So nowadays the technology has come when you, without putting off the power supply, you detect sound of sparking or tracking. So that sound will indicate that in how many days there will be a fault developed. So accordingly you can plan. So this is a predictive maintenance, condition based maintenance. Similar kind of maintenance is thermoscanning. When you thermoscan connectors, connections, and you find that unusual heat on particular connections, you further take action accordingly. So these are the condition based or predictive maintenance. Why maintenance is necessary? Number one, economy of operations. When your system runs 24/7 or you put it off as per schedule, so the operations are always cheaper. Continuity of services. When you are continuously supplying electricity to your esteemed consumers, it affects revenue, losses, and above all, esteem of the organization, the brand name. Less breakdown time. As I have given you example of partial discharge, when you know that it can happen, the breakdown can happen, you resolve it prior to that. So breakdown time is lesser. So SEFI and SEDI both are improved. Longer life of equipment. When you know that something may happen, so before the machine gets uh, faulty or it becomes non-usable, irreparable, prior to that you take corrective action and improve that by maintenance. So life of equipment is increased. So total cost of equipment over the period is lessened. Reliability and performance, definitely the reliability of machine or a power distribution system is improved. Performance, I have already told you, SEFI, SEDI. And maintenance also helps you preparation, updating for the operational need or network of future. Suppose there is a certain rate of load growth or consumer requirement, you can plan your system accordingly. A transformer is uh, load on a transformer is increasing by certain percentage of value, then you can plan additional substation, new substation, additional transformer or augmentation of transformer before the things goes beyond your hands. Advantages, the necessity itself gives you advantages, like increase system life, equipment life, and better operational efficiency. Lesser power cuts, no forced outages, and it gives you sufficient time to procure quality spares and replacement. Basically, you can replenish your store whenever these are required. Avoids uneconomical, hasty, and distress options. Any breakdown leads to some promptness, early restoration, and that may result stresses on the system as well as on the engineers or the team. And reliable power supply is one of them. So what we do while performing maintenance? So first of all, inspection. So for any kind of maintenance, we inspect the entire network. So what kind of maintenance is required? As I told you, partial discharge or thermoscanning of a network is basically inspection. You are inspecting where are fault developing and what remedies you can provide to that developing fault so that it should not turn into breakdown. Cleaning. Cleaning is the most essential part of any electrical distribution network. It includes our equipment like switch gears, transformers, lines, insulators. So these should be properly cleaned after an interval because dust itself causes many breakdowns. Care. Care means basically whatever our manual of maintenance says. So when we have to change oil, when we have to tighten our nut bolts at what torque and so on. Renewing means basically we have to change certain parts which are required before they turn into any breakdown. Adjusting. System protections may be adjusted, realigned, reset as per the load requirements, or even the tightening of nut bolts if they require. Repairs. If we find that anything which need to be repaired, suppose jumpers are not connected well or over due to thermal stress or load stress, the gap between two conductors is increased or the contact resistance has been increased, we have to take action accordingly. Activities, what we have to do, basically development of best maintenance practices. So whatever we do, we must not do maintenance just because we have to do it as per directives, but we should do maintenance ensuring that there should not be any fault for further scheduled till the further scheduled maintenance. And even we can develop tool or processes for a trouble-free maintenance. In BSES, under Kaizen projects, we have developed various handles and various tools for better maintenance. And above all, every discom should have a manual for operation and maintenance of its machinery or network. That manual must be guided by different electrical regulations and guidelines like IEEE, CA guidelines, safety measures, and the equipment manufacturers, OEM directives. Every manufacturer have some schedules for maintenance and directives. Next, we must keep record of faults so that next time we can understand what was the fault, what were the reasons, and why it has reoccurred or the another fault has occurred so that the life of equipment can be increased. Record of protective and isolating devices installed and their relay settings, basically switch gears. So when it was set at what load and what percentage, what was the time for tripping and fault currents. Schedule maintenance and preventive maintenance of all the element of distribution network must be recorded so that they can be referred as future references. It should also be providing solutions. Now with the dense population, specifically in metropolitan cities and unauthorized colonies which are not developed by the civic agencies. So we are facing challenges specifically in congested areas in Delhi, in Agra, in Ghaziabad, Meerut, and similar cities. So for such conditions, for such locations, maintenance schedule may lead to certain solutions for improvement in electric power system. We can do that also. The maintenance inspections and schedules depend upon the equipment and their functioning. They can be hourly, weekly, monthly, and annual. Like we have to take temperature and load on hourly basis, oil leakages weekly basis, and certain things which can be done on annual basis. And for proper maintenance, we must upkeep the spare part in inventory. It can be transformer oil, it can be small sockets, it can be small nut bolts, even washers. They should always be available prior to maintenance. And above all, everything has a cost, including maintenance. So we have to take care of budget and expenditures also. Maintenance doesn't mean that you can spend plenty of money on maintenance in the name of reliable power supply. For any distribution network in India, because we are monsoon hit nation, the two scheduled maintenance are carried out for distribution network, specifically overhead lines, that is pre-monsoon maintenance, then post-monsoon maintenance, or after a specified period of operations. Pre-monsoons, that when we know there will be a thunderstorms, rain, so we must ensure the trees are not touching, there should be proper segging. And post-monsoon period means when the rains are over, lines, poles must not lean about during floods, heavy rains. These kind of things happen. Sagging, broken conductors, or loosened earth wires, loosened jumpers, and specified period of operation, that is annually once in a year. Breakdown maintenance results in major because of major faults or minor fault. Major faults are broken conductors, minor faults are which can be restored, or broken overhead lines, equipment failure like transformer, major fires. And condition based maintenance, I have already told you, depend upon the condition of particular equipment line. Suppose there is a high sag in overhead line, or a pole has leaned down. So these are the condition, and you can take care or take maintenance activity proactively. Safety means any activity which is performed and the risk in that activity is sidelined, or you have freedom of that particular risk. That is safety. The safety is achieved by two things. Number one, making certain processes, like whosoever will work on distribution line will have proper PPEs, that is personal protective equipment and tools. And second thing, not only availability, these should be used properly. The staff must be trained to use these personal protective equipments and tools properly. So that must be ensured. Hazards while any maintenance activity, it is a potential condition waiting to be converted into unwanted event, accident, or incident. So that can be again when we are working in a limited space, we are not having proper tools, proper materials, or unskilled manpower, or the pathways are not kept cleaned. Hazards can be removed by identification. There is in safety a concept is HIRA, hazard and identification and removal. So we can follow those. First of all, we identify hazard and clear them. Accident, an unexpected or undesired event causing bodily injury to a person or loss of equipment or property. So we must ensure that there should not be any accident by removing hazards and properly ensuring safety. So usually, or any distribution network have certain fixed component whatsoever it is, wheresoever it is. Similar from Kashmir to Kanyakumari, as our Dr. Rajesh has said, that are overhead lines, maybe 11 kV, 33 kV, LT lines, aerial bunch cables, which are hanged on poles, HT and LT, DBs and accessories related to those AB cables, underground cables for HT distribution, LT distribution, then feeder pillars and service pillars, consumer service connection that includes service cable from DB or feeder or service pillars to up to the meters, distribution transformers of different rating and in various kind of substation, plinth mounted, pole mounted, outdoor, and so on. Switch gears that includes HT switch gear, LT switch gear, breakers and isolators, geo switches, and certain auxiliaries which are used for power distribution that includes connectors, clamps, lugs, earthing connections. These are the essential part of any power distribution. So how to maintain overhead lines? As I said, that we have to ensure monsoon and post monsoon inspection of any overhead lines. So these are the periodic. We must survey our existing line and substations for leakage, water logging, and drowning of our any equipment or cables into the water during the rainy season. Leaning of poles, broken poles, and so on. On the basis of inspection, we can arrange our resources that for a particular work or task, how much labor we require, what are the materials we required, how much time it will take. So accordingly, we can plan our shutdowns and either backfeed area, or we can announce that there will not be a supply because of this and that reason. And we ensure that our teams must work properly and work should be finished on time. What to check while survey or inspection of overhead lines? Number one, first of all, I'm written it, that is proper earthing and grounding of network. It is most essential thing for any distribution network. Then broken or missing earth wires, then sagging of conductors, loose jumper, cable connection, loose or over tight stay wires, broken stay wires, cracked or leaning poles, pole supports, trees which are touching our lines or about to fall down on our lines, because a lot many poles are broken just because of trees are fallen on the overhead lines. Bird and squirrel nests. So squirrel nest is a new phenomena, specifically in Delhi. When I joined this organization, squirrel nests were not found on our DBs or feeder pillars, but over the time open space are not available in Delhi, nor trees are available because of population, and the new colonies come up on our farm fields. So they have found a safe space in our DBs, feeder pillars, and poles. So bird and squirrel nests on DBs and overhead line poles, loose jumper jumbling on the poles, and overhead jumpers. So what to do in preventive maintenance? We must assure the space between conductors is maintained properly by stringing of conductor loose conductors or fixing spacer between LT line conductors. Proper connection of jumpers and cables. It has been noticed that our uh, workers, linemen or technicians make jumpers of underground cables of XLP insulations, but XLP is very much brittle when exposed to UV rays. So over the time, the insulation is worn out and jumpers are purely necked between two poles. So that we have to ensure jumpers are loose connections because of load and temperature variation. Cleaning of bud nets, cleaning of dirts, chemical deposits on insulators, whether these are bushings or transformers or R-pin or other insulators. The alignment of cross arms and structures is de-aligned because of storms and thunders during rainy season that can be realigned. Removal of tree branches and creepers. So tree pruning and removal of creepers is necessary. Any other issue like thermoscanning and partial discharge, so that can result into breakdown or the gap between vertical or horizontal spaces. Breakdown maintenance. Breakdown, as I told you, that when a system or network stops working. So we are failed to deliver power supply to the our consumer because of any fault. This fault can happen at any stage because as all equipments are connected into series. So any fault at any stage result into power failure in the area. So when power is failed, we have to ensure, find out where that fault has occurred and why this breakdown has occurred. And we have to remove that fault. That may take some time. We have to feedback the areas, then do necessary breakdown maintenance. That is very costly and very irritating also. Sometimes at night during peak hours, conductors are broken or fire was caught by our lines. That is problem. And these breakdowns result into unscheduled outages, interruptions in power supply, and annoyed consumers, which also bring down our performance. So higher outages lower the performance. So major faults in overhead lines are cracks in pole, broken conductors, tree fallen on lines, failure of transformers, fire in substation, or even accidents. It has been noticed in Delhi every day 2 to 3 vehicles hit our poles and they break our poles. We have to replace. These are the breakdowns. Minor faults, insulator punctures, fuse blown, broken jumpers, or lightning arresters are burnt, sagging of conductors. These are minor faults. These take lesser time to restore power supply. Predictive maintenance, as I have already told you, it eliminates unscheduled downtime of expensive equipment. Just day before yesterday, by partial discharge, we have detect a tracking in RMU, and we replace that RMU and send that defective RMU for repairs. And I'm very sure if it could have not been done, there could have been a fault and failure of the entire RMU. That RMU cost somewhere around 3 to 4 lakhs. Installation and repairing will be additional, transportation will be additional. So we have saved that cost. So reduction in cost by predictive or condition-based maintenance. But how we can do this condition-based maintenance? We have to continuously inspect our lines. We have to test them, analyze their data of testing and trends, that whether the current leakage is going on or reduced and so on. And proactive action required for these condition-based maintenances so that our breakdowns can be prevented. Next is maintenance of transformers. Though we are covering only distribution transformer, there are certain schedules for power transformers are also given. So any transformer is heart of any power distribution systems. So like heart, it pumps electricity to the entire area. So any failure of power transformer results high financial loss to the organization and longer period of outages and more revenue loss to the organization. So these are the parts of any distribution transformer, which I believe most of us know because all of us are electrical engineer working in industry or power distribution companies. Some of us may be teachers which are teaching in universities, so they know everything. I'm just passing it out. So what are the routine maintenance of any transformer? Routine maintenance means which we have a routine daily, hourly, weekly, or so on. So first of all, hourly basis, we have to read the thermometer or temperature meter of the transformer at different loads, full load, off load. But for distribution organizations, it is not possible. This is possible only where our staff is deputed, like in substations. But we have to ensure that these thermometer or temperature meters are working properly. All level for distribution companies where unattended substations are existing, we have to check it once in a while or every 6 months. Whereas for attended substations, we have to check it on hourly basis. We have to find out oil leakages. If we find that any oil leakage from radiator, gauge, bushing, transformer tech, we have to ensure that these gaskets are tightened properly, and if need replacement, we have to replace those. Abnormal noise and a vibration. If it is noticed that transformer is making abnormal, unusual noise, we have to ensure that is there any support is missing or the sound is coming from the winding due to overloading or loosen bolts. So it is something which comes with the experience. A new engineer cannot differentiate in normal and abnormal sound or the reasons of those abnormal sounds. Appearance of bolt connection wherever our connectors are connected with the transformer with bushing, we have to see whether they are properly connected or not, whether there is any marks of heat and so on. Discoloration of silica gel, if it is pink, we have to change it or reactivate. Dust and rust, we have to ensure repainting of our transformers also. For power transformer, as I told you, we have to ensure hourly basis ambient temperature, winding temperature, oil temperature, load on the transformer and voltage, output voltage. Similarly, daily we have to check oil level in bushings where bushings are oil filled, and relief diaphragm, dehydrating breather. Quarterly, once in a 3 months. Bushings, oil in transformer, cooler fans, working of their fans, any noise, bearing, motors, operating mechanism, thermostats, etc. Yearly inspection, oil in transformer, oil filled bushings, gasket joints, cable boxes, their termination, surge diverted gaps, relay arms, their circuits and proper functioning, and earth resistance as well. If we find any kind of unusual result, unexpected result, we have to either change or replace. We have to tighten bolts. If every year so that the tracking between two connectors, that is lugs and socket, should not be there. Gasket we need to replace if leaking, and if any action required to replace our protection relays, we have to replace those or test their functioning. We have to maintain transformer oil also, because it is something which keeps our transformer functioning properly. So if there is any excessive leakage of transformer oil, we have to check it thoroughly and stop it. Minor leakage, we have to address them immediately. For major leakage, if required, we have to send our transformer to transformer workshop. Minor leakages can be repaired at site. We have to check the dielectric strength of our transformer oil, that BDV should not be less than 40 kV. For that, we can use oil filtration machine on site, or if required overhauling of transformer, the results are very poor, we have to send the transformer to the workshop so that the winding of transformer is taken out, properly cleaned, repaired, dehydrated, and new transformer oil or dehydrated transformer oil fitted. So basically it is revitalizing the transformer. The fittings and accessories of transformer should be cleaned properly, bushing should be examined, cooling radiators should be examined, and they must be kept cleaned so that air can flow across the radiators. If there is any bent, any leakage, that has to be rectified. If we are taking sample for transformer oil testing, we first run off the sludge, and after running of 1 liter of oil, then we have to take sample. Buckles relay must be tested and ensured they are operating properly. Explosion vent should be inspected as per schedule. Oil gas should be kept clean. If glasses are broken, we have to replace them immediately. Dehydrating breather, as I told, we have to check them, and so on. So we are running of time. I'm speaking slide also. We have to check tightness of bolts. Gaskets should be replaced. Fasteners should be, if required, to be changed. And if required, we have to change connector sockets also. So this is construction of a breather. We all know, I'm again skipping this. The maintenance of SF6 11 kV switch gears. As BSES adopted these SF6 breakers, and most of the R switch gears which have completed their active life of 25 years, we have replaced with these SF6 breakers. We shortly call them RMU, ringmain units. So periodic maintenance of these RMUs, cleaning of switchgear panels, ensuring the relays are clean so that they can be seen properly. The SF6 gas should be in a green zone. Lubrication of operating mechanism and keep it dust free. Ensuring grounding connection, the earthing connection of body and cable must be proper. Protection system, protection relays are working properly. CDs are connected to the protection system properly. Proper connection of cable and termination to ensure that the load should not be on our bushings. Plinth of the RMU, it should be in vertical position, upright position. It should not be vented. Cable clamps, etc. So why are RMU or switch gear failed? The first of all, that is improper earthing. Earthing is not proper. The load current pass takes another route. Poor maintenance, which is obvious. SF6 gas leakage, low level of SF6 gas level, and we operate it. Improper cable termination, load of cable is on cable termination bushings. The gas leaks from that. improper size of lugs and socket or improper crimping. Mechanism of switchgear is jammed and we try to operate it forcefully. Relays are faulty, back covers are stolen or gone missing, boots of bushings are missing, partial discharge found because of any reasons, termination bushings are damaged, coupling bushing when two or more RMUs are coupled together. So coupling bushings are damaged or the gaskets at coupling resulting into moisture ingress, leakage at SF6 from chamber, internal chamber insulation failure and other external damages, improper or damaged plinth, which result into benting of RMU. So these are a few examples that because of loose connections, cracking or continuous sparking resulting into heating of our metallic part, resulting into failure of epoxy bushings or porcelain bushings. So these are a very common issue when the connections are not done properly or proper washers are not used. So due to proper cleating, the cleat is there, clamp is there, but cable is not of that particular size. So it is oversized clamp. So load of the entire cable is on the bushing. You can see it in both the cases. In the left side, the coupling is not proper. There is gap between the coupling of these two RMUs. And on the side, you can see that spring washers are not used properly, resulting into current density and heating of termination, resulting into failures. So how to ensure proper working of our SF6 RMUs? Ensure that SF6 gas pressure should always be in green zone. Never operate if it is less than green zone or red zone. So if gas is not there in insulated chamber, the arc will not quench and resulting into failure of RMU. So this is our gas pressure meter. We have to ensure that it should always be in green zone.
Sir, your slide is visible. Underground cable maintenance. Nagendra, are you getting my voice? Your slide is visible. Sir, Nagendra, I think there is some problem at your end. Your voice is not coming. You are muted. Kindly unmute yourself. We are not getting your voice. Share your screen again.
Am I audible, Dr. Rajesh?
Yes, you are now audible. Kindly go back to the slide.
I'm not able to listen you. Your voice is not coming.
Now it's okay. Are you getting me right now?
Yes, please speak up. Am I audible?
Yeah, you are audible. Kindly go back to your slides. Maintenance of cable.
Yes, thank you. Thank you. Thank you.
Perfectly okay. Make it full screen.
Is it okay now?
Yes. Perfectly okay. Please go ahead.
Thank you. Thank you. Actually, I was not able to hear anything. The maintenance of cable, usually in power distribution companies, consider that underground cables are maintenance free. But in fact, this is a myth only. Underground cables do require maintenance. And what kind of maintenance we'll discuss here. First of all, we have to inspect cables, their routes, their terminations, their connections. So most of the cables are become faulty either because of third party excavation, they dig where our cable, they damage our cable, or at cable terminations where our termination joints are failed, because we do not care of our termination once they are made and connections are made. Ultimately, when they fail, result into a breakdown, then we take care of it or we make again. Why these maintenance of cable is essential? Because to avoid failures and breakdowns, environmental damage, every cable damage means damage to environment because of digging, damaging to the tree roots, and the PVC and epoxy, which are used expensive, more expensive maintenance. It is something like when we have to replace a cable termination joint, we can replace it without replacing cable. But once it is burnt badly because of fault, we have to replace cable also. Again, we have to increase cable life of accessories. So how to maintain these cables? Routine maintenance are usually annually. We have to check integrity condition of ground connection cable joints. So basically, if it is possible to check underground joints or cable termination joints, we have to check. Even we can thermoscan. Inspecting cleanliness and physical condition of switchgear transformers where these cables are connected. So we have to open switch gears, their connections, and ensure that there is no dust, no leakage, current, no tracking. The sockets are proper, and if required, we have to replace nut bolts to tighten it properly or tighten the existing nut bolts. And we have to ensure the earth connections also. Many a times cable failed in case of fault, current is not flown through the earth, but from some point which is far distant from the switchgear. Contact resistance, we have to ensure insulin resistance test we have to conduct between ground and conductors, that insulation resistance is proper. Breakdown or corrective maintenance, again we have to do nothing, but we have to make joints or replace the defective portion of cables. Recently, one of my engineer has replaced the entire cable. Reason, the cable was got faulty and the entire cable was running adjoining to a storm water drain under the trees. The trees were grown there over the time as a part of our DDA landscape, and the entire cable is passing through those routes. So as per court's directive, neither we can cut those trees nor we can damage those trees. So we have to replace that entire piece of cable. The next and major reason of cable fault is failure due to overloading. So in case of transfer of load or backfeeding load from one cable to another cable or one circuit to another cable, we do not check that how much load is going to occur in the cable where we are backfeeding the load. So in that condition, cables are overloaded, and above all, poor planning. We haven't planned. It is assumed that for every 125 kVA we require, it's a thumb rule, one LT feeder of 3 into 300 mm square. But specifically in state distribution utilities or electricity boards, I have seen 1 or 2 feeder are commencing from 630 or 400 kVA transformer. So in such condition, cables are overloaded. That is one of the major reason. Poor handling and installation. Basically, while laying cable, these are not handled properly, not laid properly. We haven't used proper mechanisms like pulleys. We just laid these cables without proper arrangement. So how to make it put into operation? First of all, inspect the cable routes for possible damages. We have to conduct tests and find out the fault if it is underground. We have to pinpoint fault through FLCs or cable fault locators, repairing, retesting and recommissioning of faulty cable. That is breakdown maintenance. Predictive and condition based maintenance. So here we have to conduct 2 tests. One is IR test, how much leakage current is there. Second is thermal scanning. And though we also conduct 10 delta tests for cables to ensure the working and condition of the cable, health of the cable. So these are the predictive or condition based maintenance. And if we find if the length of cable is 4 to 5 kilometers and leakage current is very high, we inspect and we divide cable into 2 portions by cutting it from any joint so that we can find which cable or portion is faulty. And in such conditions, even we need to replace previous made joints. So joints can be replaced, or we have to find out the reasons from where the current leakage is occurring. The factors we have shared already. The internal factor, which is beyond damage to the cable, are partial discharge, either internal or surface due to voids in the insulation, improper drying of joints while making epoxy joints, or the bad quality of fluids, ingress of moistures and degradation of insulation because of ingress of moisture because of any puncture or manufacturing defect, crack in sheaths due to overloading or electrical stress or mechanical tensions. If cable is laid without proper soft soil bed, the stones or tree roots can cause mechanical stress, or if it is not buried at a proper depth, the roads or running vehicles can result into mechanical stress on the cable. Overheating because of overloading, deformation and ionization, etc. These are the major reasons beyond cable damage, mechanical damage. So cable faults, so we have only 2 minutes. So again, like any other fault, we have 3 kinds of faults in any underground cable. One is short circuit fault, another is open, and third is earth fault. Short circuit fault is when any 2 or more phases are short circuit with each other, and in such condition earth fault may also be there when this short is also grounded, but in many cases these are face to face faults, and it's not necessary that this fault is converted into ground fault also. So it can be tested by connecting megger from face to face one by one. Continuity break or open circuit, when there are conductor is broken in a cable and continuity is not there. Usually these are very rare faults, but do occur. I remember one case when a cable was damaged by JCB while digging. The faulty portion was repaired, cable was energized, but supply was not reached because cable was not tested for open circuit fault. Later on, digging was redone and we found that at a distance of 4-5 meter, there was a heat shrink joint. While damaging the cable by JCP, it was stretched and the ferrules were loosened and it was maintaining a proper distance. There was no short circuit, nothing was there. But IR test was conducted, it was good and cable energized, but due to over circuit, the supply not reached to the second portion. That is earth or ground fault when face is grounded with the earth. Usually such faults are occurred with the short circuit faults. So now I'm running fast. Challenges. That is the problem in all our utilities, whether private or public. Number one, any O&M engineer or office has to perform lot many activities. So there is no dedicated staff available for maintenance. No dedicated supervisor appointed for preventive maintenance. Records are not maintained of maintenance, so previous records are not available. Unskilled and untrained manpower. Though you have every resources, but you don't have skilled manpower, they are unable to give you the result. The proper maintenance is not carried out. So as we don't keep records, we don't have previous histories, we cannot get back to those and take predictive corrective maintenance. And any field engineer is preoccupied with lot many allocated works, so he has to prioritize, and maintenance is always gets a last place because system is running. So we have to repair breakdowns immediately, but preventive maintenance is at the back seat. And usually because of shortage of staff and time, no prior inspections are carried out. So many a times when we perform maintenance activity, certain issues are seen, but they are ignored because again we have to go back to the office and take the material, manpower, lot many things. So pre-inspection is very mandatory thing for any preventive maintenance or maintenance activity. And in many organizations, specifically in electricity utilities boards, I have seen the proper tool and plants are not available. Still, they are using hammers for crimping of sockets. The other challenges is no proper system of permit to work in many utilities, no check sheets that what we have to check during preventive maintenance or maintenance of any task, no standardization of maintenance. Somebody is adopting a different system, other is doing differently. Network earthing is a bigger challenge in our utilities. People are not aware that what is the importance of earthing. So usually they just do body earthing and neutral earthing, and that is sufficient. Many a times these earthings are not a different earthings. They are made from the single earthing only. Lack of motivation and awareness among the maintenance staff. So people are not very motivated that why we have to put off a running system and maintain when it is running good. They believe in breakdown maintenance. Once there will be breakdown, we'll repair it. So that kind of motivation is missing. Budgetary issues for preventive maintenance, we hardly get any budgets. Recently, I was in Uttarakhand, Dehradun. The engineers told me that it is easy to get a new feeder than to get a existing feeder properly repaired and maintained. So that kind of problem. Civil works in substation, transformer and RMU planes, fencing repairs, because these works are out of scope of electrical, they are civil works. So budget for these are not allocated. And the another issue is public support. When you have to maintain a particular substation, there is a time frame. The public wants its power supply to be restored in minimum time. Many a time our engineers and technicians do maintenance hurriedly because of public pressure. So proper maintenance is not carried out. Shortage or non-availability of spares and consumables. Consumables like oils, dhotis, sprays are not available in the store. Replenishment is very poor, or certain spares like sockets, lugs are not available in the stores. Untimely procurement. These are the challenges for a proper maintenance. If we conclude this session, the effective maintenance of distribution network reduces damages to property, environment, injury to public as well as employees or technicians. So in long term, it is a cheaper. The compensation we pay or for environment hazards, for replacement of property, reliable system, we result in a reliable system. Operation and maintenance cost is minimized by proper maintenance. Freedom from unexpected cost or risk of equipment failure. When we know that at what load our transformers or cables are running, so the chances of failure is reduced substantially. Proper planning we can implement those plannings for future load growth, future preventive maintenance or new substation, and above all, the safety of system as well as public and employees is increased a lot. Thank you, Dr. Rajesh, giving me this opportunity. Hopefully, I have done justice. So I know there is lot many questions, and I also know that the 1 hour is not sufficient to complete all these parameters. But because of the format of this Igniting Power Engineers, we have to finish it, and most probably I have done.
Thank you.
Within
Thank you very much. Thank you.
Thank you, sir.
Thank you for this insightful presentation from your end. After your presentation, if I have to summarize the thing what you have already presented, the engineering, after engineering and proper specification of the equipment we have, proper insulation and proper equipment at site, the story starts with the proper commissioning. After commissioning, the roles is to be played by maintenance engineers. And in case of any lapses on their end, there may be some problems that you already expressed. When I say commissioning, in commissioning, there are three aspects. One is the proper connection to ground, earthing, proper clearances, proper tightening, and after that, proper insulation coordination, proper protection coordination. Because sometimes what happens when everything is well in place, your protection system failed to reply, failed to operate, that also result into failure. Then after some maintenance, when some maintenance activities are carried out after maintenance, some bolts are left loose. That finally becomes the cause of failure in the shape of fire. You have done a wonderful job. You have given fully justice to your work. And I would like to start with a very common question everyone sitting here and we usually discuss in Igniting Power Engineers platform. That is, every time you look at the news of fire, electrocutions, death, and finally the blame is given to distribution company. Because the social media, you find that news of fires, electrocutions. I just want to understand, on your point of view, what do you think, what are the real causes of such failures, accidents, fires, and electrocutions that is happening on day-to-day basis? Please elaborate on that part.
It is a very challenging issue for any organization. to prevent accidents? I believe there are multiple factors. If I consider it on the part of any utility, distribution utility, it is unskilled manpower, lack of motivation among uh, technicians to use PPEs, and overconfidence. And if we consider it on the part of public or the electricity users, the people don't fear from electricity.
True.
When we were young, we have to write essay in middle school or 10th class. It was said that electricity is a good servant but bad master. So despite various uh, regulations of DE and ISI and other organization, we still use cheaper versions of material, multi-sockets, negligence, lack of earthing. I have seen that people say, what is the use of earth wire? Why should I raise my budget by using earth wire? So these are the reasons. And the technicians, because they are not trained, neither trained nor they have any knowledge about the prospective risks of using electricity. So I usually say that if you ask any electrician that I have to install one air conditioner in my house, what size of wire I should use, he'll say anything. Use 6 mm square, 4 mm square, 8 mm square. If you ask why this, he'll reply that this is thick wire and it is okay, it can bear the load. If you ask him what load he can bear, this wire can bear, he don't have any answer. Or how much current an air conditioner draw, he don't have any answer. And even if you push him to put earth wire, he says it has no use. So that kind of attitude is still existing,
My
specifically in
question
small
is, your point is valid. How to
shops,
change?
offices.
My question is how to change that mindset you have already explained, narrated, of electrician at lower level, because finally they are the
For
person who are working on the ground.
there are two issues. Number one, a stringent application of those rules regulation by electricity providers. If they refuse to issue electricity connection wherever earthing is not existing as per norms, number one. Number two is we have to train our manpower. We have to ensure that all PPEs are used properly and safety is ensured by the utility workers, technicians, engineers, lower level workers, whosoever is working at site, and awareness. And I think Igniting Power Engineers is doing that. The people who are joined here, they are aware themselves and they'll be awareing others also. And other organizations like CBIP, Power Sector Skill Council, those who are providing training, they must focus on safety of equipment, and that safety is to be ensured by public, by users and utilities as well. That
Great,
is the
great.
only solution, I believe.
And I
And grounding should be a must.
out of curiosity, I want to ask one question, because we are living in an era that is the era of digital system. Everything is based on artificial intelligence and IT. Why the distribution companies are not using this technology, cutting edge technology, state of the art technology in their system to prevent failure and to prevent accidents that we are seeing on day-to-day basis?
If you talk about the niche distribution companies like ours, that is
Yeah.
BSES Rajdhani Power Limited, Yamuna Power Limited, or Tata Power Limited, they are using all those systems. And again, I have seen that there is a lot of budget allocated to the state utilities to set up SCADA centers.
Okay.
and cloud-based monitoring of systems. But problem is that our engineers are also not up to the mark to handle those technology. There is shortage of engineers who can handle these technologies based on AI monitoring, data analysis. And trust me, BSES Rajdhani Power is using all these tools to monitor the health of their transformers. We have tools if a transformers is load unbalanced, overload, by the evening we get a message that your transformer is overload. Our protection system are so good that if there is any excessive load put on any HT feeder, the transfer feeder is stripped off. Even at LT level, we are using very advanced digital relays. So if they are set, even they are tripping at unbalancing.
Wow.
So I think Mr. KC Verma, who is heading our switchgear workshop, is the appropriate person to tell you about those relays and protection system switchgears. It will be a good thing to have him at this platform.
If he's available, he can unmute. Are you available, sir? He's here. Presently, he's here, sir.
KC Verma is, I don't know if he is.
Okay, I will call him.
He'll manage.
I will call him for next session. In the meantime, I think I have to take feedback from respected Apav sir, because he has handled distribution company for many years and he has a very vast experience in all these cases related to safety, and he can throw light on that thing. Sir, kindly unmute and say something about your view on safety procedure being adopted by.
It's an honor to hear words from Apav sir.
Yeah.
Thank you, Rajesh ji, and the presenter, Mr. Nagendra Shekhar. You have done a nice job. Thank you. KK Murthy Saab and so many stalwarts are here. I should all thank you. I wish Rajesh ji to continue on his efforts on the eradication of accidents in our country.
Thank you.
Yes, Mr. Presenter has pointed out diligently all the measures that are required. But he has also rightly pointed out the difficulties involved. In my opinion, what I think is the basic infrastructure, basic things at the first time is not being carried out by all their distribution companies, I can say. As per regulation, connection with the earth of neutral conductor at alternate pole is specifically mentioned, a PME system. And there is earthing of stay wire. Everything is clearly pointed out. So before going and finding out the difficulties of the consumer, what I want to say is that the distribution company should adhere to the norms scrupulously provided in the regulations. Regulations has clearly provided. As per regulation, I think 43, especially for the distribution company, and guarding for under regulation 71, earthing of stay wires under regulation 74, as well as there are some more regulations specifically stipulating primary and secondary side controls as per Central State Authority technical standards for construction of electrical plants and lines. Under regulation 78, they have provided clear-cut provisions, but without undertaking these basic infrastructural facilities, it is very tough to provide artificial intelligence and other fault clearing devices. It's going to be a tough job to protect the suppliers' equipment as well as the public as well. One more thing, what I found in our country is most of the developed world are having connectivity between the substations and the distribution transformers through cable screen. They are cable distribution. Unfortunately, we are having only star connected OH line without any neutral. So most of the fault current will be sent to the grounding at the distribution transformer. That will ultimately damage the transformer as well as it will impress the voltage on the consumer also. So this is a main issue which we have to. So number one, we have to concentrate on the initial standards during the erection as per regulation, at least for the upcoming substation. We are having the geography of our country, we are having crores of transformers. So at least it should be taken as a rule that we abide by the regulation and the standards for the upcoming and fine-tuning the existing installations.
Great, sir.
So
Great.
interconnection is a must. Once you interconnect, then most of our problems, whether it is the LT distribution transformer to consumers service line up to consumers, that's the interconnection. And from your ST substation up to a distribution, which is not possible. But at least you can do for the downstream, and you can fine tune the relay potential system of the substations. So this will bring down the better efficient maintenance as well as hazards in our country. That's what I can say. Thank you, Mr. Rajesh.
Now there is one query from Nagendra Shekhar. Kindly unmute.
Thank you, sir. Thank you, Apu, sir.
Jitendra ji, kindly unmute. You have raised your hand. You want to ask something. You are now ask your question. Kindly unmute.
Yes, sir. Can I hear one? Can
Yes,
you hear
yes,
me?
yes. You are audible. Please start with your question you have.
Okay, sir. Actually, thank you very much. You the nice presentation done, Mr. Sir. And actually, the nice question asked by you. The queries what you ask, that is really the need of today. I want to give some addition to your question. What you asked to our speaker, sir. Why accident happened and how we can change this mindset? Very nice question. Because we all are thinking in the direction, and right from the, you can say, the generation, distribution, transmission, the accident happened means there should be some kind of violation of the safety rules.
True.
And accidents are occurring because of two facts. One, unsafe act, and another is unsafe condition.
True.
So our speaker has given the nice presentation on the unsafe condition and how we have to carry out the maintenance of that work in order to avoid the accident. And the other part is unsafe act, and that unsafe act is because of the human errors, you can say. Because the question now related with your question, the mindset. Though we are giving the training to our employees, we are trained our lineman or foreman, but even during the working position, when he is going on the work, he is making some mistake like hurry. He is not planning the work. He is not using the safety tools. And because of that, he is inviting the accident.
True.
And that's why the accidents are increasing. And accidents are also classified. The accident occurred because of infrastructure by the utility. That is called the departmental people. Those are suffering. The accident happened to the persons who are engaged by the contractor, those who are doing the work of electrical work. That is called the outsourced person. And very important is that accident happened to the innocent people. That is called the outsider. Just like a houseworking woman, a person working in the farm. And these outsider peoples, as they are unknown about the fundamental use of electricity, they are facing this problem.
Very valid question.
And because of the infrastructure, what utility has used in the whole in India, if the snapping of conductor happened, but why snapping of conductor happened? There are so many reasons: overcurrent or the not proper maintenance. But whether we have observed that, as per CA regulation, the previously sponsor told that there are some regulation rules which are binding on the utility to follow it. But who is observing that? There is lacuna, there is some mislink between the consumer regulations and utility. And most important aspect is the funding. Our speaker sir has rightly told that we have money to erect the new lines, but we have no money to prevent or take the preventive action to improve our infrastructure. So, and second question, what sir you asked, that is also a nice question regarding AI. Let me tell you, artificial intelligence is now we are increasing in your distribution system effectively in the urban area, especially in the metro area. If you are going to see some advertise like that, Alesha, please switch on the AC. You have seen that ad, okay? That is nothing but that is the artificial intelligence. Now the people can control their household. They can switch off, switch on their devices from remote places also. And this is because of the artificial intelligence. And that is, we can say, there is one automated distributed system. We call it as a SCADA. Our sir will know very well. SCADA means there is some technology, supervised control for data acquisition. We are collecting all the data, what is going on the field, what input we have to give, and how to manage. And this era is coming now. Though what we have learned or what we have faced in our era, our new generation have not to face there. Even on their mobile, they can make on off. So this is the very nice. And let me introduce myself. Myself is Jitendra Rathod, working as an additional executive engineer in LSCDCL. I am the head of the safety management team. I am investigating accident throughout the Maharashtra. So I have joined this session to know if there are any some kind of improvement for the making preventive maintenance, or I will getting some tips. And really, I got some tips which can be useful to our O&M engineers.
Thank
and
you.
if you need my help, you can please contact me. I am ready for your help also, sir. Thank you very much.
Thank you very much, sir. Thank you. Now the time is running out, and I would like to invite PP, respected PP Vaisab, kindly unmute and say a few words so that we can conclude the session now.
Rajesh, you are getting me now?
Yes, yes.
Yeah. So my best wishes
Good evening,
to
sir.
you, to Mr. Shekhar, doing a wonderful job today. Again, today is the 28th webinar. 28th webinar. It's quite a big number. I think all my friends online will really appreciate the job being done by Rajesh. It is not a small thing. You see, he's doing day in, day out. You see, he's working for all of us. And all kudos to him, all appreciation for Rajesh at the outset that I have to say. Now, coming to the presentation, today it is a wonderful presentation done by Shekharji. He has covered all aspects of maintenance. He's covered specifically the maintenance of transformers, the breakers, the underground cables, which is creating a problem these days. You see, earlier there was overhead lines, the fault was easy to locate, but now it's really a problem area. As we're going to focus on that. Anyway, but what I ultimately the subject today chosen by Rajesh ji, ultimately it is a step for having the accident free India, because once we have a proper maintenance, we and particularly we are talking about the role to be played by the distribution companies, until unless they have total dedication, the total determination to see that all TNPs available, the people are trained and working under them. The TNP is available, the spares are available, the regular maintenance is carried out as told by Shekharji. I think accidents will keep on. Now see the transmission, the distribution lines, the trees coming nearby, sagging conductors, all those areas. You see, everybody knows but there got to be determination. And second is that the awareness of the public, very rightly said by Rajesh, by you. See, in today's days, the IT era, see, all people are having the telephones in their hand. Why can't distribution company give a one small message to the consumers? See, just awaken them every day. Let us say all the year, a small message. You see, just take care of this thing. Just take care of. So all these, they'll awaken them, and people, they need awakening. They do not know what is electricity. Very appropriately said by our speakers and other friends. They do not know. Accidents will keep on taking place. And secondly, we have to have a trained guys, trained electricians, trained contractors. You see, unless a worker doesn't know what is electricity, until as the public doesn't know what is electricity, how we expect the accident to be stopped? And on the other side, the distribution companies, if they also don't have a determination, the things will keep on going for which we are talking easy day in, day out now. So we have to change the scenario. We have to awaken everybody. As I always say, we have to awaken the worker, we have to awaken the electrician, we have to awaken the contractor, we have to awaken the ministries, we have to awaken the distribution companies, we have to awaken everybody. So until unless everybody is awakened, things will keep on going. And what is happening now, the rural areas, particularly, as I always say, 70% area remains totally neglected. No, not even a lineman does go there. How can we expect these things to? The people have to be geared up in the country where we have gone, the country where we have gone to the moon 2 days before. I think this thing happening doesn't look good. That we are not careful in a particular regiment of our maintenance of power system. We have to work hard. I say we are a team. Firstly, let us start. We as engineers under the banner of Igniting Power Engineers, leadership of Rajesh ji, we get geared up. Firstly, all of us, we get geared up. Let us say what we can do. We should try to do it. Do it. That is more important. Awaken the distribution companies first. Then ask them to awaken the public. Then ask them to train their guys. How to train them, we discussed in our panel discussion. There is a skill council in the power sector system. We get them trained. So there are already the ways and all that. Only thing we have to be in touch with the distribution companies as well, and in touch with the Central Electricity Authority, with even I say the power ministers in the states. Then we have to ultimately by and by get in touch with the union power minister and ultimately the prime minister of the country, because 20,000 deaths is as good as a sea of deaths. You cannot, one death, the pain can be very well gauged, and with 20,000 deaths taking place, I think is a pain multiplied by 20,000 is not a small thing. I think we should not, we should try to do our best. All my best wishes, and have good time. All my regards for all of you, all the members. Thank you.
Thank you, and thank you everyone. And I would like to thank all the audience present here, because we have taken the right step. We always say sky the limit. Now we can say even moon is not the limit. We have to go beyond that in the safety also. And finally, we have to make efforts to make our India free of electrical accidents and fire. Thank you everyone. Thanks a lot. Thank you, Shekhar ji. Thank you once again.
Thank you, Rajesh ji, for giving me this opportunity. Thank you everyone for listening me. Thanks a lot. And presentation is available with Dr. Rajesh. He'll share as per process. Thank you.
Thank you once again.